Hello viewers, welcome back to our YouTube channel, SC Accountants Education Center. And today we want to proceed with our series of advanced financial management. In the previous video I had talked about dealing with a single asset, and we tried to look at the statistical concepts that we use to be able to compute the risk and the expected returns. And we had promised that we are going to look at the determination of risks and the expected returns under the portfolio theory. So determination of risks and expected returns under portfolio theory. So we are now looking at portfolio, and when we are looking at portfolio, it means we are looking at two assets or an investor investing in more than one line of business. So the examiner can give you different investment proposals. The examiner can give you, let's say, can give you a school, can give you shares, and he can also give you, let's say, bonds. So these are different investment projects. You can decide to invest in a bond. You can decide to invest in shares. You can decide to invest in a school. Let me change this bond, let's say, to a pharmacy to be a little bit different. This is a pharmacy. Now the examiner will be interested in knowing how can you be able to choose which investment project you should undertake. Remember, we said there is no way we can compute risk and expected return for a portfolio that exceeds 2 investment projects. Now we are seeing that here we have a school, we have shares, we have also a pharmacy or a pharmaceutical business. So if you have 3 business ideas that you want to invest in, if we want to look at the risk and return as far as the scope of advanced financial management is concerned, we are going to specifically look at only 2 investment projects. But now you are seeing that the examiner has given you, 3 projects. So we are going to formulate what we call the portfolios. You can either decide that you are going to invest in a school and shares, or you are going to invest in a school and a pharmacy. So it means there are going to be 2 investment projects. So once they have given you these 3 portfolios or single assets, because each of these is a single asset, you can invest in a school as a single line of business. You can invest in shares as a single line of business. But we've said that once you are dealing with a portfolio, it means these investment projects are more than 1, but they don't exceed 2. So we are trying to compute the risk and return associated with each of these individual items. And that's why we are trying to form a portfolio, because these 3 projects can't be executed at once, because we don't have a statistical method that we can use to compute risk of a portfolio that has more than 2 projects. Two, we don't have a method that we can use to compute risk of a portfolio that has more than 2 investment projects. That's why here the first thing we do, we first formulate the investment projects. In other words, we first form the portfolios to be 2. And I said you can choose to go by maybe a school and shares. The other, you can decide to take a school and a pharmacy. Or you can go by taking shares and the pharmacy. So those are the different portfolios that we can have. Meaning, if you have those 2, you can either say, I'm going to invest in a school and shares, or I'm going to be investing in a school and a pharmacy, or you can invest in shares and a pharmacy. So it means we are going to be having 3 investment projects. These are 2, these are 3. But each investment project forms what we call a portfolio. So we need now to know what is the risk and return, the expected return for each of these portfolios. And that's what we are basically want to compute. So once you have formed these portfolios, then you can go ahead and substitute into our different formulas, the statistical formulas that we have. So the question, if the question, let's say, is looking at different portfolios, because one way the examiner can give you the different investment projects and it will be you to form those portfolios. The other way is that the examiner can set for you the different portfolios that you can use to make the computations. So once we have formed our portfolios, then we go ahead and compute the expected risk, the expected return, and then the risks. So how do we compute the expected return of a portfolio? Expected return of a portfolio. In other words, when we have 2 investment projects. So we've seen previously, we saw the expected return is actually E into X bar for the single project to a summation W RW, but this R bar. So that was this was just the probability, and this is the return. Or this one, you can call it the weight. Of course, you can also just put I equal to 1 per n. But now, since this was for only one item, one asset 1, but now once we are dealing with 2 assets, the formula changes. 2 assets, or what we call a portfolio. The formula changes slightly. So the expected return of a portfolio, I'm just going to call it RP. Expected return of a portfolio will be, this is WA, weight A, RA bar plus weight B RB bar, where the WA is actually the weight of asset A, weight or probability of asset A, of the asset A. Then this RA bar is actually the expected return of asset A. Then the WB is actually the weight of asset B. Then RB bar is the expected return of asset B. So that's the formula that we use to compute the expected return of a portfolio. We just sum up the expected return of asset A plus the expected return of asset B. We just sum them up. Once we add them, then we get what we call the expected return of a portfolio. This is the formula that we've been using for computing the expected return of a single asset. So you just sum up. But when we go to computing the risk of a portfolio, the formula is completely different. So let's look at how do we compute risks of a portfolio. This is now the formula for computing risk of a portfolio. So the problem is actually on this risk of a portfolio because the other one is a little bit easy. We know that for us to compute risk, we need to be knowing the standard deviation. So we know that risk, the measure for risks are measured by using standard deviation. But now, the standard deviation of a portfolio will be equaling to the square root. This is weight A squared times standard deviation of asset A squared plus the weight B squared times standard deviation squared of asset B plus 2 weight A dot standard deviation A for asset A times standard deviation of asset B times, this is lambda A comma B. The whole of this is under square root. So that's the formula that we use. Now we need to define all these. So here we are adding, even here we are adding. So this is, the whole of that is we multiply it, even this one, where, of course, we know that this represents the standard deviation of a portfolio, this one here. So we are going to define each of these: weight A, weight standard deviation A, weight B, standard deviation B. This is weight A, standard deviation A, standard deviation B. This is lambda. The whole of this is representing one item. So let's continue. This is weight A squared is actually weight of asset A squared. Weight of asset A squared. Then D, of course this is standard deviation, squared A. This one is standard deviation of asset A squared. Then WB is representing the weight of asset B squared. This is WB squared. Then standard deviation B squared. This is standard deviation of asset A of asset B squared. Then WA is actually the weight of asset A. This one is not squared. Then WB is the weight of asset B. Then we have also standard deviation of asset A. Standard deviation of asset A. Also have the standard deviation of asset B. These are not squared. And then this lambda here is the one that represents the coefficient, the correlation coefficient. This one is representing the correlation coefficient. This is correlation coefficient of, it is actually correlation coefficient between asset A and asset B. So it is between A and B. So that's the formula. And this formula is also provided in the formula sheet. It's the one that we use to compute. The whole of this is correlation coefficient of asset A and asset B. So we need to look at how do we determine the correlation coefficient of asset A and then the correlation coefficient of asset B. So this same formula, it has been given in the formula sheet, but for it they wrote it as SP equal the square root. This is W small a S squared, WA squared, S squared plus WB squared, SB squared, this is SA, plus 2WA times R, of course this is lambda AB, times SA times SB. These S, they represent the standard deviation. This is standard deviation of asset A. This is standard deviation of asset B. This is weight of asset A. This is weight of asset B. The whole of this is the correlation coefficient of us between A and B. This is weight of asset A. Of course, this one has there's also the weight B. This is weight A times weight B. So that's how it is written. But as I told you, this RA B, it's also a symbol to represent a lambda. Is the correlation coefficient between asset A and B. So it means that this lambda A is also the same as, you can write it that way, which is the same as correlation coefficient. So it means the same thing here. So we need to understand, how do we compute the correlation coefficient? So for us to compute the correlation coefficient equals to convariance, between A and B, convariance of A and B divided by standard deviation A times standard deviation B. So S standard deviation A times standard deviation B. Or in some other books, they write it as conv, but it means the same thing because it's just a short form of convariance. They use conv A B over the standard deviation of asset A times the standard deviation of asset B, where the conv A to B is the convariance of A and B. Then, of course, this represents the standard deviation of A and B. In other words, you can call it standard deviation or risk, because we know the measure of risk is what we call standard deviation. So this is risk A, risk of A. Then, of course, this is risk of asset B, or the standard deviation of asset B. But now we have seen that we have also introduced in a new term, this convariance of A and B. So how do we compute the convariance? So for us to compute convariance, or what we abbreviate as conv of asset A and B, is represented by summation P into, let me just put it down here. This is conv A and B. So this one is represented by summation P into RA minus RA bar into RB minus RB bar. In other words, where this P is actually the probability of receiving these returns. P is the probability, this one is probability. So this RA is the return. This one is representing the return. Then RA bar is representing the expected return. Then of course even this one expected return of asset A. This is the return of asset A. So this one is representing return of asset B. This is the expected return of asset B. So mathematically, the convariance is written as conv into xy, which is equivalent to summation P into x minus x bar into y minus y bar. We know that this is actually the expected return of asset X. This is the expected return of asset Y. So this is the probability P. Then this is the return of X, return of Y. So whichever way they have expressed it, that's how we explain it. So we've seen that for you to be able to compute the risk of a portfolio, you need to understand there are very many formulas that are going to be involved. The first one, they have given us the exact formula for computing the risk of the return. But within the formula, we have seen that we have got two extra items that need separate formulas. So for you to be able to compute the risk of a portfolio, you need to first know how to compute a correlation coefficient. And this correlation coefficient also brought something new, which is the convariance. So there is no way you will get the risk of a return, the risk of a portfolio, if at all you have failed to compute the correlation coefficient, then the convariance, because these two, they are the ones that are feeding into the final formula that you are going to use to compute the risk of a portfolio. So those are the different formulas that we have as far as computation of the risk of a portfolio is concerned. The one for a single asset, that one was very easy, because for a single asset, we said we just look at the coefficient of variation, and then we look at the standard deviation. There were only two methods, but here the methods are two. The methods are more than one, because you are going to be using more than two formulas to arrive at the risk of a portfolio. But now we need to understand, how do we interpret our results? Interpretation of the results. In other words, what are we interpreting? We are interpreting expected return of a portfolio, and also we try to interpret the risk of a portfolio. So we need to understand the answers we have gotten. You are not just going to make computations and you leave them there. We need to make, like, we need to comment and give advice. So that's what we are going to look at in the next video. We try to look to understand, how do we comment when we have, let's say, a convariance? How do we comment when you are looking at correlation coefficient? Then finally, how do we comment when we are using the other on the results that we have gotten on the expected return? Because the expected return is going to give us a different answer that will feed into the computations of the risk of a portfolio. But In each of the two, we comment differently. So we are going to look at the different ways of how we can comment basing on the formula that we have used to compute these two aspects.